don't think we're going to put a special phrase in this one. Not yet. I just posted the video a half an hour ago, though. So.
Yeah, I looked yesterday and I was motivated to do it, and it was.
Oh! Calling me out. Motivated. That doesn't even ever happen.
And then it wasn't there, and I was like, well, I can't do it now. Is it really over? I was like, no. Is it similar to this?
To yesterday?
Yeah.
Yeah.
You'll be fine. Will I?
Yeah. Yep. No big deal. Yep. So, yeah, once you know what I do today, yesterday will be easy. So what I want to do is I want to look at volume by washers. Everybody know what a washer is? Anybody play washers like the backyard game?
Yeah.
So I've never played it. How does it work?
It's basically like beat make combo with tiny metal discs.
Yeah, but so do you have like a board like this? Are there like 3 spots where you can throw the washer?
One hole in the center.
There's just one hole in the center.
It's like a square with a.
Okay, some people are disagreeing with you, Alex. Like some people are saying that. Okay, so you just got one. Okay, there's like carpet on it? Okay, so like which one is worth, so I'm assuming this is worth 3, and then 2, and then 1?
If you're standing, if the board is like in front of me, the closest like thing is 1.
Really?
If you're shooting to it.
Well, it would seem to me like this one should be worth 3.
Why?
Because it can end up moving that direction. So then you catch like 2 or you catch 1 on the toss. You know what I mean?
I mean, I guess it just depends on your life.
Okay.
I always do it from 1, 2, 3.
Okay. All right. Well, maybe we have maybe that's how we should end calculus class. A day of backyard games.
Yeah, I'd be for it.
If it's warm enough.
And I what?
Stairs.
Cook for us.
I can cook for you? Who says I can cook? Pork chops.
It's at 2 3/4 worth of heat.
All right. So what I want to do is we're going to use a method called washers. It's pretty cool. So we got area between 2 curves. You've all been here for area between 2 curves, right? And so if I draw just a little shape right here, I'm just going to draw a rectangle to represent the area that exists. Okay? And what I'm going to do is I'm going to take that rectangle and I'm going to rotate it around the x-axis. Notice before when I rotated it around, it was a solid shape, wasn't it? But now when you rotate this around, there's going to be a hole right in the middle, isn't there? There's going to be a gap. And so instead I get this. It usually takes people a little while to draw it. Yeah, it looks like a pea tree. Nice job. Toilet looks like a toilet seat. We're identifying things like pea drains, toilet seats, things that for the rest of your life you'll think about calculus now because you'll see those.
I don't think that I will.
All right, so we want to find the volume of that thing. We want to find the volume of that washer, that pea train, that whatever it is. And so we're going to find the thickness. Does it have horizontal thickness or vertical thickness? Horizontal, so it's got thickness of dx. And then yesterday we found the area of that, shape. What was the area of a circle we said? Pi r squared. Do you know what the area of a washer is? Yeah. Yeah, very good. So it's pi times big R squared minus little r squared. Well, that's the larger radius. So what we're going to do is we're going to find the area of the larger circle, then we're going to subtract the smaller one out of it. That's all that does. No big deal. and we just attach a dx to it, and instead of doing one of them, we do an infinite number of them. What? What did I do? Okay. So if you look at this situation here, the formula for volume by washers is pi times the integral, we'll say from a to b, whatever the bounds are. And in this case, can anybody identify what the large radius would be? The distance from here to the top of the washer? What determines the top part of the washer? G of x, right? Yeah. So in this case, it would be g of x squared minus, and then what determines the bottom part of the washer? Yeah, f of x. So all we have in this unit, we got area between two curves. We have discs, which we did yesterday. We have washers, and we just have one more thing after that. We got time. Let's try a problem. You guys did really well yesterday. I like this one because this kind of ties with something that we've done. Another problem you guys have done on a different worksheet. So I'm going to look at this guy here and here. And so find the volume of the area bounded between y equals x squared and x equals y squared rotated around the x-axis. So we're drawing these in class, but on your worksheets, hopefully the area should be drawn for you. So describe for me y equals x squared. What does it look like? Parabola. Then how about x equals y squared? Yeah, it's a sideways parabola, isn't it? Like that, right? And really the only part I'm concerned about is the part where they intersect and have that area. That's the part that we want to use. Everybody good with that? Okay, so I'm going to take my little eraser here and get rid of little parts of this just to clean it up a little bit so we don't look at all that stuff. We don't need everything. There we go. That's kind of our region. Okay. All right. From yesterday, do people remember what the intersection point is? 1, 1. Yeah, that's the coordinate where they intersect. Way to go, Shelly. All right. And so I want to take that area and I want to rotate it around the x-axis. So what I'm going to do is I'm going to draw a sliver of the shape. I'm going to rotate it around the x-axis. Yeah, so trying to visualize is kind of tough. I realized when I had done the first one, it probably didn't turn out quite the way I like to. I realized that when I make these washers, if you notice, I shade opposite sides. You know what I mean? So for the inside here, I try to do the right, and then the outside I do the left, and it gives it kind of that three-dimensional look. Just kind of cool, right? Yeah. Yeah, it's artistic. So, so here's what I do. This is the work that I show, and this is especially important for the lessons that we'll kind of look at, whether that be on a tomorrow or on Monday. Don't think we're going to be able to move on tomorrow. But so I draw the washer over here. And there's some things I probably do a better job teaching than others. I think that this is a pretty good one. I see this come up on people's work on the AP exam. Teachers grading the AP exams, they like this. This really helps you see what's happening. And what I'm trying to do is I'm taking that washer, I'm pushing it off to the side, and I'm going to draw the different dimensions that help us figure out the volume of that shape. First of all, again, thickness, dx or dy. dx. So that means that all of my variables must be x, okay? So dx is determined that all of our variables must be x. What makes up this middle part right here? What is this thing right in the middle that it's rotating around? The x-axis, which is just y equals 0, right? Yeah. And then as we look at the graph, what makes up the inside of this washer right here? Is it y equals x squared or is it x equals y squared? Which one makes up this guy right here? It's y equals x squared. And what makes up the top one? X equals y squared. Very good. So notice how we can't have x equals y squared, can we? Because that's a variable of y. We need a variable of x. So what is it going to be then? Yep, y equals the root of x. Good. Square root both sides. Excellent. So right now it's not a big deal because we're rotating around 0. But later on we're going to rotate around things that are not 0. Okay, we might rotate around the line y equals 2 or something like that. So what I want you to see is that this is little r. And in order to determine the little radius, you take the top minus the bottom. What is x squared minus 0? X squared. And then this is big R. And you take the top minus the bottom, which is square root of x. In this situation, because you're rotating it around y equals 0. That could change. If we were rotating around y equals 2 or something like that, it would change. That's not for today's lesson, but I'm trying to show us something that will help us later on. Yes? I take this one minus the bottom and this one minus the bottom. Yep. Yeah, I don't subtract these two. Yep. Now we're gonna set up our formula. Our formula for washer is this: pi times big R squared minus little r squared, and in this case dx. So I have pi times, what's big R squared? What are you gonna get if you square big R? X. Good. And what if you square little r? X to the 4th. Good. Dx. And we're going to do an infinite number of them. And where are we going to integrate from? 0 to 1. Yep, we're looking for x values. We're going from 0 to 1. And that's our integral setup. Do be ready on your test to set up the integral. Also be ready to take the integral, and as you have it, be able to actually evaluate it all the way through. No big deal to evaluate this, right? Antiderivative of x. Yep, so we got x squared over 2 minus x to the 5th over 5. Plug in 1, and we get pi times 1/2 minus 1/5. The half minus a fifth. 3/10. So I get 3 pi over 10. Isn't that clean? What? We'll try again. Because I also used a circle. And we don't use circles, do we? We use rectangles. Circles are for like grade school mathematics. Circling your answer. We do boxes. Right. Okay. Let's try this one, and then we won't do the last one. We're gonna have you guys kind of go to your work and stuff. But it says find the volume of the area between y equals 1 over x x equals 2 and y equals 2 rotated about the y-axis. So first, let's get a general idea of the shape. 1 over x. Yeah. So I've kind of got this thing going on, right? X equals 2. Y equals 2. Everybody good with that? Can you see the region that I'm working with? Okay, so that's my shaded region. All right, we're rotating it around what? The y-axis. So as I rotate around the y-axis, instead of drawing a vertical rectangle to flip, I'm going to draw a horizontal rectangle to flip. Cool. Let's draw that horizontal rectangle. So that horizontal rectangle has a thickness of dx or dy? Dy. You guys are doing so well. And I'm going to rotate it around. It's a washer, right? Yeah. You just want to what? You want to play washers. Okay. All right. Backyard games. Here we go. Sometimes I have good ideas. It's okay. I always say that 1 out of 3 ideas that I have are good. The others aren't very good. So I'm going to draw my washer off to the side, and I'm going to try to identify those really important spots. This is something that I remember I was trying to figure out, is where do we draw these lines? Do I draw them on the right side or the left side? And to tell you the truth, we draw them on the right side because that's where the original area is made. See what I'm saying? Like if the yellow part was over here, then we would draw them on the left-hand side. Where you get my point? It does. It does. Yep. Yep. Okay. So I've got that. I'm going to draw this one right here. I'm going to draw this one on the side. Okay. And I like that. Helps me organize my work. What makes up the middle? X equals 0. What makes up that inside part of the washer? Ooh, so Kenzie said y equals 1 over x, and she already solved to get x equals 1 over y. Are you okay with that? I'll write it down. So she did y equals 1 over x, and then here she had x equals 2, right? So see how they're x equals equations, and I have thickness of dy. Therefore, I can't have y equals 1 over x. I'm going to have to solve for x equals. So I'll solve. Y over 1 equals 1 over x. As we cross multiply, xy is equal to 1. And if I divide by y, I get x equals 1 over y. Better? So I'm going to take this piece right here, and I'm going to write x equals 1 over y. Cool. Any questions? We okay with that? Sweet. Let's do purple. What's the big radius? 2. And just to be careful, okay, doesn't really matter in this situation because you can see it, but when you're going sideways, it's always right minus left. Okay, right minus left. So you can see a big radius equal to 2. Kind of nice when you come up with a whole number like that, isn't it? Yeah, makes it real nice. And then this is going to be our, oh, that was really bad. Wow. There we go. Little r is equal to the distance from here to here. And that distance again is just right minus left, so 1 over y. Remember, what's the formula for a washer? Pi times what? Big R squared minus little r squared. In this case, we're attaching a dy for that volume piece. So I have pi times, what's big R squared? 4. What's little r squared? That's the volume of one of those shapes. We want an infinite number of them. So when we look at the volume and we look at the balance here, remember, are we looking for y values or x values? Y values, because it's dy, right? So what's this highest part there? 2. Would everybody agree I don't go all the way down to 0? I go, what's the y value right there? 1/2. How'd you get it? Yeah, so this is x equals 2 right there. So if you plug in a 2, 1 over 2 is equal to y. So the y value is 1/2 right there. Like that coordinate right there is an x value of 2 and a y value of 1/2. 1/2. See that? So, all right, let's evaluate it. What's the antiderivative of 4? 4y. Excellent. And then what's the antiderivative of negative 1 over y squared? So it'll be a negative y to the negative 2. So I'm going to add 1 and I get right? So it'll be plus. So plus 1 over y. So we have pi times, I plug in 2 and what do you get? 8 plus 1/2 minus what? I plug in 1/2, I get 2, and then if I plug in 1/2, what's 1 over 1/2? 2. So you have pi times, looks like 8 minus 4 is 4 plus 1/2. What's 4 plus 1/2? 4 1/2 or 9/2? 9 pi over 2. If you look back up at the shape, you know, how would you describe that shape? Does anybody have a really good, like, what's that going to come out like? Anybody know? A washer. Okay, yeah. That's like kind of the slice of it, but if you had like, you know, a whole one, it would, I don't know, like the end of a trombone maybe, something like that. You know, I don't know, not a bad idea. Anybody ever made a bunk cake?
Yeah.
A bunk cake? Yeah, where you kind of got that shaper that, you know, yeah, maybe something like that. I don't know. Anyway. All right, take out your homework.